Hey viewers, today I'm looking at a HP computer screen, quite an old one now, model number LA2206x, and the complaint with this one is it turns on but just has a white screen, completely white, and doesn't respond to button pushes or anything. It's almost like it's brain dead, and we've just got a backlight coming through, so that could be interesting. It comes on a large stand. I've removed the stand. Allows you to rotate the screen into portrait mode as well. They were a bit of a fad a few years ago. I guess they were aimed at desktop publishing and whatnot, so you could have it in portrait and look more like a book of a page or something, I guess. But yeah, let's crack on and see what we can find. So the first thing we should do is confirm the fault. So we'll turn it on. We have a blue light in the corner. And yeah, a very white looking screen. Bit of a nasty smudge up over here. Not sure if that's on the surface or what. But other than that, no. Nothing. I'd expect an OSD, maybe a HP logo or something initially, and something that says no input signal. So we'll turn that off and carry on. So along the edge, the front bezel is clipped in all around. I actually found it easier to start on the vertical edge rather than along the top and the bottom. And yeah, just got to sort of get your spudger in and push the clips in that way. You can see the clips are on the front edge and they let go from the back panel. So just take your time, work it around. You shouldn't be able to, well, you can damage the edge of the case if you're not careful, but and it's on very tight, so you just have to figure out how they release and then away you go. It's a lot quicker. Now there is a electrical connector right here, just a small plug that plugs in the back for the button panel. That should pop off easy enough, but just be careful if you start tugging away at it. Just want to make sure you detach that in a nice friendly manner rather than just pulling on it and hoping for the best. Little long nose pliers, and there's that little plug there. Now it looks like the LCD is mounted, well, all of the board and everything is mounted to the back of the panel, and it appears that it's just going to fall out of the plastic housing, so we'll tip that upside down and give it a wiggle and see what happens. So if you lift it up evenly on each side, then it comes off quite easily. If I was lifting one side first, it tended to jam on the other, so just lift both sides. And then we see typical construction of a lot of computer screens, everything mounted to the back of the panel. Looks like there's a large metal housing / bracket right across that's screwed on each end. There's two screws on each end, so if I remove them and then the whole thing should flip over. We can see around under the metal foil here be the cable for the panel and of the buttons there. If we lift that up, where's that going? Oh no, sorry, it's just the button cable, but there will be a cable to the on the top side. There's one to the LCD panel, so when we are moving this, we want to be careful we don't damage that. So this is the top of the panel where the flex comes through to the LCD connector. With the screws loose, we can lift that up. There's the flex, and we'll probably try and detach it from the panel side rather than the board, just because it's probably easier than trying to flip this over and get at it. I don't know if this is... Can I flip it over? Let's have a look. Let's have a look. Oh, there's actually another connector over that side too. Yeah, I think it's going to be easier to take it off at the top side. There's another connector over there on the other on the edge, which could be a bit tricky to get to. Is probably for the backlight connector. So I think if we just take this off, there's a couple of little clips each side, squeeze it in and slide it out. Then we lift that up, and then you can see the connector down the far end there, which is, there's our insulating panel for the bottom of the power supply. Oh, and it actually tucks up under the board there, so no, oh no, yep, we can unplug that. Just a little white plug in the bottom. There we go. Pretty sure this is actually LED backlit instead of cold cathode. So first thing I'm going to do is remove the power supply and have a look at the obvious culprits, our favourite electrolytic capacitors. And obviously if the main board's not turning on due to lack of power or what have you, then the backlight side may be running. It may be getting no control from the main board, so we'll be looking at maybe its default is always on, full brightness. Okay, unhook the wire there, and oh, hang on, rookie mistake. Don't forget the two screws holding the power connector on. Take two. There we go. Spin her around. What do we got? Nothing obvious. Don't you love that? So, no markings on the board as to what voltage rails we have going off to the motherboard, but that's fine as long as we have a couple of something we expect, like 5 and 3 ish. So we'll flip it over, plug it in, start probing around. That over here you can see, yeah, backlight driver board, definitely an LED backlight. Here's our connector going out to the motherboard, so I'll be checking down the pins along here. We got 4.7 on there, nothing. .7, 4.7, nothing. Obviously we're going to have some ground wires, we're going to have signal back from the board to control the backlight. So at the moment we've got 4.6, 4.7. That should be enough. I mean, capacitors can fail without bulging out the top and give you a noisy signal, which can upset the systems. We could put the scope on it and see if it looks like it's clean-ish. So it looks like a fairly clean 5 volts, 4.8 volts. If we could also AC couple that and lower the voltage just to see what sort of ripple there might be. That's actually really clean. It's 20 millivolts per division, so that's way down. There's no noise coming through on there, so it looks like our fault is likely on the main board. Rookie mistake number 2. Don't forget these little nuts that screw into the sockets. You won't be able to get the board off until they're off. Of course they're there so that you can screw your cable retainers in there so you don't pull your cables out accidentally or they don't fall out over time. But yeah, they do actually hold the board in as well. Looking at that, there's nothing really obvious. I'm going to take the flex off, the screen flex off, so it's not flapping around all the time. Which has an interesting retainer on it. I wonder how that works. Oh yeah, it just lifts out, pulls out on the edges. There we go. Haven't seen one like that before. Oh, it's just a row of pins in there. Alright, let's scratch our head and think where to start. Well, I guess one thing we can do to see if this board is alive is put a scope on the LVDS connector to the screen and see, do we have... Okay, system is on. Let's try for pin number... I'll start at the left hand end. What have we got there? Oh dear, that looks like data. Who knows what that data is? It's a whole bunch of lines. If you could read the matrix, maybe you would see what the image is. Well, that's interesting. So, because of that, I'm inclined to say our processor is alive. I think we have a panel fault. So now we need to find out if we're getting power to the panel, which will come from this connector, and likely, by the look of it, from pin 1, because I can see transistors and so forth and stuff. So if I just scope those, and we'll just see if pin 1 has got some power on it. It does. 1, 2 and 3 are all connected together. 4 is unused perhaps. We've got a pair, we've got a data pair, we've got a noisy, possibly maybe it's an unused data pair, I don't know, it looks like rubbish, unless that's some sort of clock. Maybe it's a clock and I haven't got my scope set right to see it. More data. So all of the pairs appear to have data and power. Let's have a look at the board on the panel, see if there's anything obviously popped. I mean, there is every chance that this flex is either damaged or where the connector was in just needed reseating. Maybe the connections are gone a bit dodgy at either end. We might find we plug this all back in and it might just work. Alright, we'll plug it in and see what we got. There's a couple of points on the LCD panel here. One's marked 5 volts. We'll have a look at that one and make sure I've actually got the socket turned on. So here we go. We've got 5 volts there. There's one marked 3.3. That looks okay. What else have we got? Looks like just all of the differential pairs for the LVDS signal, video signal. Now, if we have a look on the underside of this board, so here's where the connector attaches. Oops. Here's one chip. I'm not entirely sure what that does. Probably processing of the video signals. Unless they're passing them straight through to the panel, I don't quite know how they address the panel, because there's a lot of these flex ribbons. 1, 2, 3, 6 flexes going to the panel, so that's a lot of extra wires, but it looks like possibly feedback and sync signals and so forth. So there's that. This is pretty sure that's our 3 volt regulator. We've got a fuse above that. The 5 volts comes in through that fuse. if we have a look over here, there's a very definite switching supply right here, as you can tell by the inductor, couple of capacitors, quite a large capacitor there. What's the rating on that? I think it's 16 volt, and traces running off to this IC here, which is obviously doing the switching for this inductor. So having a look around and trying to figure out what that does, on the board here, the only markings I can see to try and hint to something is over here near the inductor is their VAA, and VAA, I'm not entirely sure what that stands for. I did a quick Google search to see if it was standard naming conventions for LCD panels, and couldn't really find anything. But if we have a look at the output of the coil and just touch on VAA, where are we? Does it go to there? What about this V? There's a VGHP as well. It should, is that going through to there? It's under the chip. No. Interesting. What about that capacitor there? The yellow capacitor. Okay, so the yellow capacitor goes through to the VAA pin, and okay, yeah, so it goes through the inductor. Here we go. Through the inductor, through this diode, to the capacitor, to the VAA pin. So you're not going to get anything off the end of the inductor because you're measuring through the diode. So this capacitor relates to the VAA point on the board, whatever that means. But I think we need to find out what this chip does. So if I measure the VAA pin while it's running, and we're not getting anything on there. 70 millivolts, not even that. Yeah, so whatever that chip does, I don't think it's working. We need to find out what exactly it's supposed to do, see if that might be our problem. So this chip is a TS-1640 Compaq TFT LCD bias IC, voltage regulator for gamma buffer and reset function. So I guess if it's not running, we're not going to have gamma and what have you, and no picture like we have. So what does it say? Up to 18 volt boost converter with 4 amp switching current. Now that's a pretty big inductor and capacitor they've got on there. So given that it's a 16 volt capacitor, we're going to be expecting that sort of voltage on it. So the fact that we have nothing is a flag. And if we have a look, let's have a look down at the pinout for this thing. We've got our reg, that must be reg out, reg in, regulator feedback. There's another FB pin there, because we've got our V ins and whatnot, and we have there in the bottom pin 13 enable EN, and yep, datasheet says in logic high to enable the device. So first things first, we need to make sure that this has supply voltage going to it, and supply voltage being 2.5 to 6 volt in, so we're probably expecting 5 volts given that's what's on the board at the moment. And with the enable pin needs to have a high, so probably a 5 volt, 3 to 5 volt to tell it to turn on. And if that's present, then there's every chance that this is not switching as it should, and there's a couple of reasons. That could be maybe the feedback line. There's a problem with the feedback line. There's a resistor divider network, so it'll get a certain voltage feedback to tell it how much it needs to run to create the desired output. So in order to do this, of course, I've had to take the main board and power supply unit and flip it over, as you can see there, so that the board can flip with the flex cable and we can make our measurements. It's a bit hard to see from underside what pins what. I don't even think they come through to the underside. So we'll get you focused on the scope, because looking at the board while I probe it is not really informative. Right, we'll plug her in. You're looking at V top, if you can read that. I'm not sure how clear it is, to see what voltage levels we have. And if I find a plug, so what are we getting? About 30 seconds before it timed out. Plug it in. So we're going for the V in first, which is the end pin. Our V in should be, is that 5 volt? There we go, 5 volt. And our enable, which is the middle pin 13. Oh, 3.4 volts on enable. And it's not switching. I've got nothing going on there. I've got 5 volt supply on the inductor and nothing happening. But why have I got 240 millivolts after the diode? That's interesting, isn't it? Maybe our diode's off. If our diode's gone, it's not going to get the right feedback to switch properly, is it? It's not even trying to switch. That's very interesting. Let's unplug that. Let's check this diode, because the end of the diode is mounted so close to the capacitor that I can't get a probe in there. So here we go with a skinny probe. Just make sure it is connected to this capacitor. Yes. So I am on the right track there. And if we take a diode measurement across this, we should see half to maybe 0.2 if it's a Schottky diode, which I'd sort of expect. Oh, we've got one that's very climbing. Look at that. Our rectifier diode is, that appears to be stuffed. It climbed up to about 1.6 volts. Yeah, it's still climbing. Just got to get good connection with the probes. It's all over the place. The feedback is going to be on the output, which is a couple hundred millivolts. It's not 5 to start with, so it can't be happy with that at all. I'm going to see if I can find another diode. Okay, so the diode on the board is a SK210. This data sheet here tells us that it is a peak reverse voltage of 20 to 100 volts. The 210 is the 100 volt model, so that's peak reverse voltage of 100 volts. Normal current of 2 amp forward. And what else have we got about that? Peak forward current of 12 amps. Yeah, and a surge current of half sine wave of 50 amps. But we're not going to be hitting that sort of current, I severely doubt. So the only one I've been able to find that comes close is from a panel that I took out of an LCD TV. It just happens to have a similar looking circuit on it, different chip, but I'm picking it does the same thing. And the diode on that one is a SCD34, which according to this is a peak reverse voltage of 40. So Now if we're switching 5 volts across a small coil, what are the odds we're ever going to get to 100 volts as a peak flyback voltage? I don't know. I don't think we will. As far as its current capacity goes, this one is 3 amps forward, continuous, and 80 amps surge, so it certainly can handle the current. It's only the reverse voltage, but hey, I think it's worth a shot. It's a different package. It's got the surface mount, it's got the little cutouts in the ends like that, whereas the other package is just a standard surface mount with the leads tucked under the edge. But what do we got there for size? 5 mil across. That one's about almost 5. It's going to fit on the pads, I think. So let's swap it out and see what happens. Now, do I want to use hot air on this? These little flexes that are somewhat glued to the board, really. I don't believe they're soldered. I think they're some advanced glue. I wouldn't want to get the board really hot and encourage them to peel off. Obviously they're applied last and the components are put on first, so I might just try and use a solder iron on one end and see if I can get it hot enough to just float free, get the heat through the diode, and just have it float freely off the board. Yeah, I think that's going to be the safe bet. I've put some flux over it. May help conduct some of the heat through the flux around to the other side. This is going to be lead-free solder. I'm going to crank the iron up to 380 Celsius with a sort of a largish tip on it. You might have seen Dave Jones's recent video about solder irons. Well, guess what? I've got one of the crappier designs, of course. That's the old style with the element in the wand, and the tip sits over the element. It seems to have come up to temperature pretty quick, but yeah, see, there's the tip, and that just slides over the element. The element's not built into the tip like the new all the rage units that I really should have. So, you know, heat transfer, it's been shown to drop when you put the tip onto the board. So we'll get it cranked up nice and hot to start with, and let's see how long it takes to come loose. We'll be adding solder as I go. And get the tweezers ready as well, I suppose. Where are my tweezers? I've lost my tweezers! Lift it. I don't want to rip it off the board. That'd be bad. Sort of wonder what sort of temperature the iron is currently dropped to. Let's try with a hot air on it just to encourage it. I'm running the hot air at about 180 Celsius just to try and take some of the heat out of the board. Oh, there it goes. Might be enough to grab the other end with the solder iron. I just pushed it sideways. And we'll get down in there with the iron. Here we are. Look at that. Alright. What an abortion, but we got there in the end. Clean up that solder. Running out of time. My camera doesn't want to stay on, and I'm almost at the finish line. At least I hope I'm at the finish line. So let's have a look. I've got it on. I've confirmed it's connected, and yeah, it measures a lot better diode drop than the other one did. Although strangely enough, I checked it out of circuit, the old one, and I was getting 0.3 volt drop. So it might have had like an internal connection issue, and getting it really hot has caused it to come right. But I mean, if it works, we'll know that was the problem, and if it doesn't work, then who knows. But we got to try something, don't we? So I'm going to plug the panel in now, and I'm going to scope. We should have our 5 volts. There's our 5 volts. And if I scope the line that we were looking at before, and that went off scale, so if we go 10 volts per division, and we now got 12 volts coming off, so that was a bad diode. But do we have a picture? Right, kill the glary lights. Let's plug it in and see what happens. Is it gonna go? Oh! Look at that. Check video cable. Red, green, blue. The colors that make your life enjoyable. Well, I hope you found that video useful. Proof again that you don't need schematics to fix complex circuits. And if you're looking for a quick fix, hey, here's the answer. Maybe you can go straight to it, but you know, it's always fun to try and work out the problems on their own. Always good to keep junk around. As I said, I stole that part from a T-con panel off a TV. It had pretty much an identical circuit. What you see here is the control switching regulator IC, which is switching this inductor, and the diode was right above it. That's the one that I stole. So monitor going to sleep. Yeah, so it's good having junk around. But there you have it. Thanks for watching, and I look forward to you viewing the next one.